Okay, so actually, it's kind of like a nice teaser for what we're going to be covering today, anyway. So it's one of those where you don't quite have to get it or fully understand the concept after we do this problem because we're going to do a whole lesson on it. But this is a good way of kind of getting us geared in the right direction. All right. So they give you a table. This is what's known as a contingency table. Right. But basically, all it is comparing two variables. So you have a variable that is gender and a variable that is handedness. All right. So they don't really talk about what the purpose of the study is, other than to just make a determination of what the breakdown is by gender. All right. So they try to sound like casual in their speaking, but it's cool. You know, it's better than other textbooks that cost money, so we accept it. Let's denote the events. M equals the subject is male, F equals the subject is female, R is the subject is right-handed, L is the subject is left-handed. Compute the following probabilities. Now, if you're given a problem like this on your own and you have to come up with a notation, feel free to not make any of these statements if they're painfully obvious. Like if you write P of M, I think any reasonable person is going to look at the M and say, I suppose that M probably means male, right? So you wouldn't have to make the let statement, right? But in this case, they did it for us, so who cares? Now, they're asking us for the probability, okay. Suppose I should turn the pen on. Well, best laid plans, right? Like, I'm going to use this app now. Well, I guess I'm not. All right, I'm going to use the other app because they didn't fully activate this app. Why wouldn't they fully activate an app? Because some would say, why would they fully activate an app? Optimize. It's not going to be really optimal. Yeah, I knew it. They said optimize it. Optimize it just means that they're just going to make it fit their stupid software. All right. It's funny though, because OneNote works on just about every other device that I've used, except for these. So P of M. So if you didn't look in the textbook, then this problem is foreign to you. Yeah. Yeah, it's the online textbook, the OpenStax. Yeah, exactly. So P of M. $180. All right. So that's looking for the probability of getting a male, just in general. Now, it's a good question, but it doesn't seem like we have all the information because if we're talking about probabilities, we're talking about the number of ways in which you could be successful. So the number of males over the number of people.
That was page 180.
Page 180, yeah. All right, so I got the number of males, kind of. So it's broken down by right-handed and left-handed. If I create a total column, then I would have 52 males overall, because I just add them. 43 plus 9. All right. So now I know how many males there are. That's good. I needed that information. But I still don't know how many people there are. So let me figure out how many well, actually, I kind of do. They gave it to us, but let's say I didn't. They didn't give us that information. I would have to take the total number of females, which would be 48, add them together, and get what's known as the grand total. Right, which is the 100. Now, in this case, it's a good self-checking situation because they told us that it's a random sample of 100 individuals. So that's going to mean that if I got something other than 100 for that entry, then I did something wrong. All right, so the probability of getting a male is 52 out of 100 because there are 100 people. Now, for part B, it's saying the probability of getting a female, same idea. We know how many females there are, 48 of them. And we know how many people there are, there's 100. So that one's a little easier. For part C, we're looking at the probability of being right-handed. All right, so now I'm changing my perspective. I need the totals for right-handed and left-handed because ultimately I'm going to need the left-handed individuals. So I'm going to add those values together. So I'm going to really just kind of expand my table to include some totals. And in the process, make it a little bit more colorful. So 87, 13, and I just very quickly verify that 87 and 13 are going to give me a 100, and that does happen, so that's good news. So again, probability of being right-handed is going to be, by definition, number of righties over the number in total. So however long it takes me to write that out, because of this friggin' app. See, the patience with this thing is wearing thin. All right, so we have 87 people that are right-handed, and we have 100 people overall. All right, probability of being left-handed, same idea, except I have 13 lefties out of 100. So I got all those probabilities. Now, honestly, if I'm evaluating left-handed and right-handedness, I don't know that I would look for any of these numbers, because since the total is 100, the grand total, whatever the values are in the table itself, they represent percentages, right? This process is useful when the grand total is something other than 100, right? Because let's say the grand total is 150, then 48, that 48 for females wouldn't represent 48%. It would be 48 out of the 150, which would be a smaller percentage. All right, so you would want to do the calculation so that you can conceptualize what those values are. Now, E through I are all kind of like just, at this point, reasoning. I'll show you a more structured approach in a little bit, but they're all reasoning at this point. If I were to say probability of getting a male and somebody who's right-handed, all I'm going to do is look in my table for right-handed males. All right, because it has to satisfy both criteria. The individual has to be right-handed and male at the same time. So anybody who's in that category would necessarily be a right-handed male. So that's 43 out of the grand total. Same idea with left-handed in male. Female, sorry. Female and left-handed. And I was about to write it backwards anyway, so this was going off the rails right off the bat. So F and L. So female and left-handed, so we're looking at the intersection between those two categories. So find where female and left-handed come together, and you see that there are 4 individuals who are female and left-handed. Now this is a random distribution from, it seems like it's from a population, right? They didn't really assign context for this, but what we just kind of got out of this is that left-handedness is rare to begin with. You know, generally speaking, the rule of thumb is about 10% of the population is left-handed. But, and this is a small-ish sample of 100 people, but what we just gathered here is that finding a left-handed female is even more rare than a left-handed male, but only for this sample. So we don't know if this projects out to the entire population, but if that's true, then any activity that in which a female could specialize in by being left-handed, then that's something that a left-handed female would really like to be aware of, you know? So, for example, my son went to they call it a round table, the New York Rangers round table, and the hockey coach, the Rangers coach was talking, and you know they give words of wisdom and answer questions about the team and things like that. But one of the things that came up was that they're always looking for right-handed defensemen. And I was like, anytime they say right-handed anything, it's always a surprise to me. I'm like, what do you mean? Like, why would you want right-handed? Right, they're all over the place. You can find righties. Like, raise your hand if you're righty. You know, like it's most of us. You know, so. So I was surprised by the fact that it was righty. But if you go to baseball and you ask a coach what they're looking for a pitcher, baseball, softball, they're going to say left-handed, right? Because that's what's more rare. So like if you have somebody who can pitch left-handed, they're going to make it further than a person who could pitch right-handed, because even if a person isn't like the best ever as a lefty, they're still one of the only available lefties, and one of the best abilities is availability. So that's kind of like a little niche there, where if you're a left-handed female, you might say, wait a minute, I'm thinking scholarships, thinking about getting into college, you know, opportunities. Maybe I work on pitching, softballs. You know, that's the kind of thing that you might kind of cultivate. But you don't know that going into the situation unless you study the analytics, you know. So it's like you got to sit in front of a computer and work on all these things. But, you know, you just had a kid. You're like, all right, time for some data analysis. We're gonna map out this kid's life for the next X number of years. You know, it doesn't play out that way all the time. I'm sure there are some people who do it, but it's stuff to be mindful of. Like when I was applying to colleges and they had the big book of scholarships, I was thumbing through that thing. I believe it was called the Big Book of Scholarships. I don't know if it's still called that, but it's probably some online version. But one of the scholarships that was offered was only available to left-handed people. So scholarship for lefties. I'm pretty sure that still exists. So, you know, it's just something to be aware of. That just became a public service announcement. That didn't really have anything to do with the problem. It's like, yeah, find some characteristic about yourself and just start looking it up, because odds are there's a scholarship for you.
Question about the answers. Are you going to want us to put it in the smallest fraction?
No. My recommendation is leave it in unsimplified fraction form, because you never know what you're going to have to do with these numbers. And if you had to add this, like let's say later on even in the same problem, there's like 10 parts to this problem. Later on, I might have to add one of these other numbers to one of these numbers to another number. It's easier to add fractions if I have a common denominator. So for practical reasons, I say leave it unsimplified, and also just for peace of mind, you don't have to worry about rounding. You know, so the big concern about rounding is not that you'll remember the rounding rule, it's that you'll carry it out correctly. Not you individually, but you collectively. You know, there's always somebody who makes a mistake, and I don't like taking off those points. So leave it as a fraction, and you'll be good. The calculator, in a lot of cases, will automatically simplify the fraction for you. Don't go out of your way to try to unsimplify the fraction. If the calculator gives it to you already simplified, just go with it. But take this as kind of like a gift and run with it. But sometimes I will say, for your own purposes, in order to analyze the situation, you may want to put it in decimal form just to get a sense. So like, for example, these are out of 100, so I'm not worried. Like 4 out of 100, that's 4%. All right, but if it was 4 out of 127, I know that it's going to be less than 4%, but I might want to know exactly what it is, or at least have an idea in my mind. So I'll pop it in the calculator. I won't write that number down, but I'll keep it in my mind as like, oh, okay, so that's what that is, you know. But that's really for me rather than for like the producing it as a solution on a test. All right, for part G. M or F. All right, so getting a male or a female. All right, now this is a weird one. So the logical connective or. I'll just say the logical or. Very, very rarely, but every so often, a word in real life and a word in math mean the same thing. But most of the time they don't. You know, it's like, oh, well, I know that word from real life, but in math it means something completely different. Right? So, or is one of those hybrid words where it almost means what it means in real life, but it's just different enough to be confusing. Right? So I'll give you a quick example. If I were to say that I am either wearing blue jeans or a red shirt today, true or false? That's my sentence. I'm either wearing blue jeans or a red shirt, like a fully red shirt. I don't get into like, oh, there's a little bit of red in it. Not that. But like all red shirt or blue jeans. Would you say it's a true or false statement? I'll just give you a little. True, right? Okay. Now, if I were to say that I'm wearing a gray shirt or black pants. True, right? I mean, I'm assuming that I'm colorblind in the gray, brown-ish transition. So I did come into school one day with purple pants on because I thought they were gray. But once they hit the fluorescent lights, I'm like, there's a little bit of purple in these gray pants. And the students are like, a little. Geez, what are you, the Joker? And I was like, dang, that's harsh. So, but yeah, they were bright purple. I just couldn't see it. So I threw them away. I should have just kept them for like posterity. But anyway, so true, right? Because it's one or the other. Now, if I were to say that I'm wearing either a gray shirt or blue pants, what would you say to that? You could say true, but it kind of feels like a choice, right? In a lot of cases, like, well, I'm wearing both, so is it true if I'm wearing both? Well, yes, logically it is true, but it feels like it should be one or the other, all right? So that's the issue that we always kind of bounce back and forth between, where in real life, the word or, like if I were to say, you can either go to math class right now at this time, you could go to math class, or you can come with me and grab a bite to eat. That's a choice, but not because of the logic of it, but because of the logistics of it. All right, the logistics of it are that you can't physically occupy two places at the same time. All right, unless you're like Skyping or something like that. I mean, you're still not physically doing it, but there's ways around it. But logically, if there was some way that you could transport your essence from one location to another and occupy two different locations, then yeah, sure, it would be fine. Logically, it would be a true statement if you were in both places, but you can't physically be in both places, but conceptually you could be. All right. So if either part is true, and I'll be very clear about this, or both, of a sentence containing or specifically, I don't want to have to write that because it's hard enough to write on this as it is, but I'm just going to circle it here. It has to have the word or in it. Then the sentence is true. All right. All right, but I've had enough people over the years. This is why I talk about the pants and shirt, because I've had enough people over the years say, "Well, you're wearing both, so false. You said it had to be one or the other." And like when you start getting into, you have the language barrier in some cases, but then you also have the logical reasoning component of it, and then you put it all together, it becomes sometimes a jumbled mess. And then the idea that you've been working with this word "or" in algebra classes before, but it never really it was explained. I'm sure it was explained very well, but it never really, it was not made a big deal of. I'll just put it that way. Like when you solved a quadratic and your answer was x equals 2 or 3, you presented both answers. It wasn't like the x was equal to 2 or 3, and then you said, well, I'll just take the 2, because it could be one or the other. You put both answers down because both were correct. But what happened was, in that context, the "or" somehow disappeared and became a comma. And it got kind of replaced with an "and" conceptually. Like, these are my answers, 2 and 3. But those are the two answers that satisfy the "or" condition. All right, so it's very strange stuff. And I'll tell you, if I had any interest in being a lawyer, I would have done a great job on that LSAT exam, because I remember helping my wife prepare for it, and she was doing the logical reasoning questions, and all they were and, or, conditionals, and biconditional sentences, just in context. So Tony bought a car, and like all that stuff, But I was reading through them, and she's like, I keep getting the wrong answer. And I'm like, all right, you're going about this the wrong way. What you need to do is take that little sentence right there. You call that a letter, whatever you want. Call it N for Naomi, And then here's another one, B for bank, and then just put a little "or" symbol in between it, because that's what the connective is. Now think about the ways in which this could be true. And then all of a sudden, and the question would be like, well, which of the following would be false? So you have 3 ways in which the sentence could be true and 1 way in which it could be false. And there it was. And all of a sudden she went from like not getting hardly any of them right to getting them all right consistently. Just because it had nothing to do with like your critical thinking, your reading comprehension and things like that. It had to do with your ability to recognize the logical conditions that exist within each problem. And so that was it. Off to law school and extreme amount of debt for the rest of our lives. So anyway, M or F, male or female. So if any part of this sentence is satisfied by that by this chart, then it has to be included in our probability. So probability of male or female. So I just go through and say, are you a male? Yeah. Are you a male? Yep. Are you a male? No, but are you a female? Yeah. Okay. You come in too. Are you a male? No. Are you a female? Yep. Okay. So it had to be any of them. Well, I got all of them. 100 out of 100. Now, you can reason this out too, because you could say, all right, I got all these people together. You could take the 100 people, put them in this room. It'd be tight, but you can get them all in here. Break the room up into quadrants. And then, well, lopsided quadrants. Put your 43 right-handed males over here. All right. Put your 9 left-handed males, tuck them in the corner. 4 female left-handers, tuck them in the corner, and get all the females that are right-handed over here. All right. And so walk into the room and say, all right, raise your hand if you're either a male or a female. Everybody's hand's going up, right? So then the next one would be, raise your hand if you're either a male or right-handed. All right, so visualize the room. Probability of male or right-handed. Okay, so again, you have the whole room organized. Male righties are over here, male lefties are over there, female lefties are over here, female righties are over here. So raise your hand if you're either a male, so all the males' hands go up. Raise your hand if you're a righty. Those males and those females' hands go up, all right? So now you're looking at, and you could go to the chart and say, all right, what does that correspond to? Little check marks for me help, because not everything lends itself to 4 corners of a room, but it does get the job done. So male righties, female righties, and then again we were just looking for males in general, so the male lefties can come in too. The only people that would be excluded would be the female lefties. So instead of adding up all of the people I want included, why don't we just subtract the people I don't want? Right? So I don't want the 4 female lefties, so that would be 96 people that I do want out of 100. All right? So with the same idea in mind, I would say probability of getting a female or lefty. So you visualize the room again. So these are all righties up here. So male righties are out. I don't want them. Put an X there. All right. Lefties I do want. So the male lefties, you're in. The female lefties, you're in. And if you're female in general, you're in. So basically everybody but the male righties. So that's 57, because I don't want the 43 people. 57? Yeah, 57. Out of 100.
Can you go back to H one more time? I'm a little lost.
So you're...
Understand the males and I understand the right-handed ones.
So I want all of the males, so that's each of these folks.
Okay.
And I want all the right-handed, so I want these folks also. So I want this group, and this group. So I'm saying I want everyone but this group.
Bump that.
Yeah, so these are the ones I don't want.
Female lefty.
Female lefty. So what I did was instead of adding these up, which wouldn't have been hard, I just said, well, 100 minus 4 is going to be a little bit easier.
Okay.
So why not just do that? No problem. Now, J is one of the ones I kind of alluded to last class, where I said that different books have different ways of representing not. Okay, there's a complement symbol. We use the tilde. This is the same as P of not M. So it means not. Highlighter. All right, I use the tilde notation, but unfortunately, I mean, it's a free textbook, so that's never going to be unfortunate. But they do some things a little bit differently. All right, they both mean not. All right, so slight adjustment. If you ever get jammed up on anything like that, you see notation that's completely unfamiliar, you look through the packet and it just doesn't, you're like, what is that? You can do one of two things. Just sit tight on it, talk to me about it in class like we're doing. Or if it's really pressing, send me a message and say, what the hell is this? You know, did we do this in class? Is this going to be on a test? You could have like full-blown panic mode. For J? Oh, that's just saying that it's the not symbol.
Not.
Yeah, it's the textbook's way of saying not.
Not.
Right.
N-O-T?
N-O-T.
Okay.
And so we use this symbol. And so the only challenge that we have here is just understanding that the question is asking us to find the probability of getting something, or getting an individual who is not a male. Which is the same as, in this case, finding the probability of somebody who's a female, which we already know is 48 out of 100. All right. Now, the last three are conditionals. So that's where I'm going to stop this problem for now. We'll come back to it later. It's still a very good problem. But I want to go through the lesson first before I come back and do this, because that part I don't want to hand wave our way through, because the logical stuff that you have background in that, you've worked with logical reasoning before, whether it was a formally instructed sort of thing or whether it was just kind of like this where somebody said and both parts of a sentence have to be true in order for an and sentence to be true, or either part has to be true. Like that's generally how it goes, but there are courses that actually go through the structures behind logical reasoning. Discrete mathematics is one of those courses. They offer something here. It's not called discrete, but it's the same thing. I'm just trying to remember what they call it. I gotta look it up. But if you're interested in logical reasoning, because maybe you're pursuing a field or a career in computer science, or you want to go on to the legal field, because like I was saying, the LSATs is like 1/3 of the entire exam is going to be logical reasoning, then maybe you do want to take a discrete math course. It's pretty interesting stuff. Okay, so let me actually save this as its own video. And just remind, page 180, 3.3. Okay, so 3.3.